Hello everybody. Now let us study grain science and technology subjects related to the grain. In the next 2-3 classes or maybe all 5 classes in this week, we will devote on this aspect, which will include different matters or processes related to the storage of the grain, what are the various factors that cause the spoilage of the grain, how to measure the grain quality, infestation in the grains and so on. So, in today's class we will study grain storage. Hope you know the situations of cereal grains in India. I will start the lecture with this. If you look at the data available on food grain production in India, we find, it is generally shown that the production of food grains have grown on an average 2% in the last 2 decades or so, and which is higher than that of the average rate of the population growth in the country, which is generally about 1.5%. The total food grain production in India during the year 2017-18 was estimated to be 277.49 million tons. Approximately 60 to 70% of the total food grain produced in the country is stored at the home level in indigenous storage structures. So, the indigenous storage structure etc. also become very important component. Rest around 30 to 40% enters the urban market channels and public distribution system. So, in the process, whether it is in the, if you add total, that is in the storage, home storage as well as in the market channels or public distribution system, it is estimated that on an average basis 10 to 12% of the total food grain produced in the country is destroyed, is lost during storage, and this is a significant loss. So, obviously, one need to take appropriate measures to reduce these losses. So, means that is at least storage condition, proper storage conditions etc. should be maintained, so that the losses are minimized if not completely eliminated. So, let us see the various factors in the total value chain of the grains, that is starting from harvesting and to the its processing and packaging. Various factors operate and the various different losses, types of losses, like in the case of harvesting there may be shattering, there may be loss due to molds and birds attack, in the transport spillage loss, breakage losses etc. So, in all the like harvesting, transport, processing, pre-processing or post-processing, packaging and storage, various that is stages to which grain passes through. If you compare, you will find that is during storage it is the maximum loss or the maximum factors that is takes place. So, in the storage it may be insect attack, mites attack, moths, rodents, molds, bird sprouting, moisture migration etc. are the different factors which cause the loss of the grain in storage, during storage. So, in this picture we have seen the stored grain ecosystem. When the grain is maintained in any conditions, there are various factors, that is the ambient conditions, conditions inside the storage atmosphere, conditions of the grain, that is if the moisture is more, moisture is less, grain that is the respires, it produces heat, it might produce carbon dioxide, it might do. So, there are different interactions, there may be the grain temperature inside, that is maybe more or less. So, different interactions, and all these interactions may facilitate or may cause problems in the growth of the insect, mites, microorganisms, etc. So, basically it becomes an important aspect to study, that is the grain ecosystem, that is how the interactions between various components. Let us see, you can see here there is wind, solar radiation, ambient air, ambient temperatures, then inside this grain and the continue, all these things that it will influence the, or it may provide conditions favorable, it may provide conditions unfavorable for. So, accordingly that is storage facility is selected, and the environmental desired environment to control the growth of insect, mites, microorganisms, all right, etc. like conditions which favor this growth, like moisture, temperature, insects and rodents, that is these etc. These are the factors which influence the grain losses. I told in earlier slide also, that is. So, quality before storing the grain, type of the storage bin, use of pesticide and fumigants, mechanical loss factors, general conditions of the location of the storage godowns, etc. All these are the factors which influence the grain losses, and accordingly these factors, they may be more, they may be high, depending upon the storage ecosystem. So, it is very important to maintain a proper ecosystem inside the storage facility, so as to or minimize the effect of these factors on the grain loss. In this slide, you can see that these are the conditions, that is the conditions for safe storage of cereal grains, that is how the shelf life or storage life of the grain varies with the temperature as well as its moisture content. And obviously, if the temperature is more, relative humidity is also high, it has comparatively less shelf life. Okay. The temperature is more, relative humidity is high, it has comparatively, that is less shelf life, its temperature is less, relative humidity is also reduced. So, its shelf life will be more. So, you can see here even 12 to 30%, that is the moisture content, is the one which gives a shelf life more than 1 year, even for the temperature 90 to 35 degree Fahrenheit. So, it becomes 13%, it becomes 12 to 13% a safe moisture content for the storage of the cereal grains. And to maintain the storage ecosystem, aeration is one important process. We will come in the towards the end of the lecture also on this aspect, that is a process of forcing air through grain to reduce its temperature in order to preserve them from deterioration, and perforated ducting on the floor through which the air can be blown into the grain. They are used, and this can be, which is generally called plenum chambers, etc. In this slide, see here how the aeration, that is whether depending upon the temperature, ambient conditions outside is more or high, accordingly one has to have a cold air system or warm system, and movement of the gas air movement in the storage bin, that is the first A is the warm, and B is the, that is the cold is A and B. In the case of B, it is the warm air, and the movement of the gases accordingly, that is inside the grains, etc., which they are there, that is easy movements of the air facilitate for the proper control of the temperature, and therefore, that it prevents the insect attacks and mold growth, etc. So, that becomes very important, that is the storage ecosystem as well as the conditions prevailing this for minimizing the losses or increasing the shelf life. So, obviously, there is we should take appropriate steps like the appropriate storage structures should be used for maintaining proper ecosystem in the storage facility. These are the major steps to reduce the storage losses. So, some considerations for the storage structures, that is, it should be elevated and away from the moist places, so that the proper maintenance of the safe moisture inside the storage facility can be facilitated. The storage structures should be airtight even at loading and unloading ports. It should be rodent proof and clean, and it should have it should be plastered with an impervious clay layer to avoid termites or insect attacks. The points that one should remember for safe and scientific storage of food grain are the site selection, that is the proper site, conditions surrounding the storage facility, etc. Storage structure, that is type of the storage structure, the cleaning and fumigation, aeration and regular inspection of the grain stock. That is how the quality is maintained inside the storage facility. These are some of the important steps, important points that are required to be noted down, or that steps that are required to be taken in order to reduce the grain losses. Now, let us study the different types of grain storage structures, which are used traditionally as well as scientific storage structure, especially with special respect to our country in India. That is, the grain is generally stored either in bags or in bulk. So, the major types of structures for storage of grains include traditional storage structures, improved storage structures, modern storage structures and farm silos, are structures which are made on farm storage structures. You can say the traditional storage structures normally include Morari, Bukhari, Kothra, Mud Kothi, Muda, Kanja, etc. Improved storage structures include Pusa bin, brick cement bin, bunker storage, cape storage and so on. The modern storage structures include silo bin and deep bin or even sheds, and farm silos include tower silos, horizontal silos, pit silos and so on. So, in the next class one by one we will have little details of these storage structures. So, Indian traditional grain storage structures, that is, in this one category is the underground storage structures. Here in this table I have tried to give you some common or important underground storage structures, their local name, the state where they are popular. For example, Khani or Patra, they are the underground storage structures which are popular in states like Orissa and Andhra Pradesh. They are dug out with sides plastered with cow dung. They may be of rectangular shape, having the diameter, maybe dimensions, depth 150 centimeter, sides 150 to 200 centimeters, and the capacity may vary from 2 to 3 ton. The Khai, which is popular in a state like Rajasthan, it is some sort of well dug inside and in the ground or underground. It is lined with the stones or sand cement. It may be either circular or rectangular. Its depth may be 600 centimeter, diameter also may be 600 centimeter in case of circular well. The capacity may be up to 60 ton or so. Above ground traditional structures include the Kothi, which is popular in states like Bihar, Punjab, Uttar Pradesh, etc. They are made from unburnt clay mixed with straw and mud cow dung or brick and masonry works. They may be cylindrical or rectangular in shape. their capacity may vary from 1 to 50 ton, and accordingly dimensions may also vary. Khangi, which is in the Karnataka or Mysore region or in Maharashtra state, they are made with bamboo plastered with clay. There may be normally is cylindrical. The capacity may be 1 to 20 tons. Similarly, Kotha is the popular above ground storage structure in the states like Punjab and UP. They are made from a small shed, that is the small shed built with brick and masonry work. They may be cylindrical in shape, and its capacity may vary from 5 to 100 tons. Accordingly dimensions are vary. The other Indian traditional structures may be gunny bags. The bags of different sizes ranging from 35, 50, 75 and 100 kg. They are used with or without plastic lining. That is mostly they are used for short term storage of grain. They are stacked grain put in these bags are stacked one above the other. You can see in the figure here. Then the mud and earthen structures, different structures of this type in different part of the country which are used. You can see in these figures, they are normally made with the clay, straw and cow dung. That is these three materials in the proportion of 3:3:1 is used for making them, and these structures are made, sun dried and then burnt in fire. Their life may be 8 to 10 years, and however during rainy season they might develop cracks and the moisture absorption is inside the grain is followed with insect and mold infestation. The other type of structure, Indian traditional structures may be bamboo structures. You can see here in this figures, split bamboo woven in the form of a cylinder with wide base and narrow mouth. Their lifespan may be 4 to 5 years. The wooden structures are made by using local wood and they are painted black. Okay. At the top about 30 centimeter to 20 centimeter inlet, and at the bottom about 30 centimeter to 15 centimeter outlet is provided, and the life of these wooden structures may vary from 15 to 20 years depending upon the conditions of the locality surrounding and also how they are used. They are neither airtight nor moisture proof. So, other traditional grain storage structures may be kothar, morari, bukhari, mud bins, etc., which are used or which are common or popular in different parts of the country. And in these figures you can see that is what their layout and how they are made, their dimensions, etc., are provided. Sometimes they are used, the bamboo splits are used, in other case that is timber ceiling may be provided, some inner outer frameworks, bamboos and bamboo splits. So, and mud bin may be used with that is muds, etc., clay and all. So, these are different types of Indian traditional, but of course these structures are not very effective. As you can see, they have all one or the other problem, like the moisture maintenance, aeration and all those things are difficult, and accordingly the grain quality which is kept in these structures is not very good, or sometimes they do not have very good shelf life. So, the drawbacks of those Indian traditional structures have been overcome or removed by suggesting or by means of this developing improved storage structures like the Pusa bin. You can see here in this picture, that is it was developed by Pusa Institute. Okay. Here low density polyethylenes which are sandwiched with mud are used for this bin. Moisture migration during storage is minimal because of the good insulation properties of these bins. So, the moisture migration or moisture maintenance, humidity, etc., which is one of the problem in the traditional storage structures is to some extent is overcome in this. Another is the cap storage structure, that is cap means cover and plinth, that is plinth from the bottom. You can see here in this structure there is some sort of plinth is provided for keeping these grain bags etc. So, plinth from the bottom and then cover from the top. So, these they are covered with some plastic or some tarpaulin etc. So, this type of open storage is considered as transit storage and serves the purpose of storage of food grains in bags for short period. Then the other is bunker storage. This type of storage structure is used for long term storage and also when a comparatively larger volume of the grain is required for storage. So, for this bunker storage becomes a good structure. Then the coal tar dump bin for improved structure is another, can say that it is a low cost and easily available material, coal tar drums. It was developed by Central Institute of Agricultural Engineering, right, CIAE, and the dimensions that are provided here. You can see that these are the different drums. The grain is put into these coal tar drums and they are stacked one above the air. Okay. The domestic hapur bin was designed by this Indian Grain Storage Institute. It is made of galvanized iron and aluminum sheet and its capacity may vary from 200 to 1000 kg grains. After that, now let us discuss modern storage structures. We have discussed common Indian traditional structures, improved structures and then modern storage structures. Okay. And these are normally used not only in our country, but also in several other countries globally. They are used for bulk storage of grains and they include conventional godowns, that is sheds designed for bagged storage, and then silos. The godown side walls are made of brick or stone and have sloped roofing in asbestos or corrugated galvanized iron sheets over steel trusses. The silos are constructed from steel or reinforced concrete. They may be of two types, maybe shallow bin or deep bin. Squat silos come under shallow bin, and a squat silo has a wall height to diameter ratio of 0.5 or even less. In the vertical silos come under the category of deep bin. You can see this in the picture. L is the line of rupture. And how in the case of shallow bin, where is the line of rupture? In the case of deep bin, the line of the rupture is little below. So, this categorizes that shallow bin and deep bin one can say. The bulk storage of food grain normally in India is taken care by various agencies are there like Food Corporation of India, Central Warehousing Corporation, State Warehousing Corporations, grain marketing cooperatives, state government agencies, or nowadays many other non-governmental organizations also are coming into this practice, and these are the which agencies generally which regulate or which take care of the bulk storage of food grains. And basically the bulk storage has the provides certain benefits like the running storage cost or maintenance cost of the grain inside the storage facility etc. generally is low. It results into the lower losses through spillage and rodents etc. It is an efficient and effective system as far as the fumigation and aeration is concerned. It needs less land area and less labor requirements. The aeration and fumigation, that is even the complete control of the aeration and fumigation is possible here by having appropriate instrumentation etc. It is possible to store the grain for longer period of time, possible to store moist grain for short period of times, and more importantly in the bulk storage structures, that is all the operations like loading, unloading, transportation, etc., all those things, these operations can be mechanized. So it provides better efficient and controls, and also the lower cost, etc. So different in the different bulk storage, you can say that is layout of the stacks of grain inside the godowns is shown in this figure. There may be 8 stacks per pile, that is the first pile, second pile, third pile, fourth pile, etc. In this first pile there is 8 stacks, in there 5 stacks. So how there is the different bags, they are stacked one above the other, that is so that they provide the proper strength, and also there is a proper space for the aeration inside. So you can see 1, 2, 3, 4, 5 like this, then the stacks, and proper space is provided so that the not only for the movement of the air, but for the personnel and the machinery for the loading and unloading. So in this 8 bags are kept in one stack. Here the 5 bags, 1, 2, 3, 4, 5. This is 5 bags, but there is a proper space is maintained in within all the sets to have a proper aeration. So this type of system that is in the rural commodity storage structures, or even in the urban areas and in the on-farm, these can be maintained, and these bags can be maintained inside storage. So these are some of the systems for layout of stack. So for proper aeration, proper fumigation, and of course this facility it will be better, it is better, so that it should be maintained leak proof. Then on-farm storage structures include pit silos. There is permanent pit silo is a circular deep well which is lined all around the side and sealed from the bottom, so that water may not rise into it. That is the soil water, field water. About 22.5 centimeter thick wall is used, and it becomes a satisfactory 25.5 centimeter thick, and it works satisfactorily up to 15 meter depth. Corrugated metal steel dome or half pitch roof with ample overhang on the all sides may also be provided. So you can see here in this pit silos. The other are the trench silos, which are made in the farm or in the field. There is the areas where the soil is deep and water table is generally low. These trench silos are made. Tower silos, they are cylinder in shape, made of masonry wood or metal. The mechanical ladder, because they are very tall, so generally mechanical loader or a large capacity of blower, etc., might be required to fill the material or to blow the air, etc., to maintain the proper air and temperature inside. Aeration and fumigation, as I had told you earlier, it is the process of moving air through stored grain at low flow rates to maintain or improve its quality. Aeration can provide 3 major benefits in the storage of grains. It cools the grain and slows down insect activity. By cooling the grain, aeration prolongs the effectiveness of pesticides, and aeration can provide an appropriate drying function as well. So this in the green, the different facilities in the picture, you can see that is how these different aims for the drying bed, again they are maintained. And also the set of basic design parameter suitable for cooling of dry grains by aeration are the air flow rate, maybe the in the silos, maybe 0.8 liter per second per ton air flow rate might be required. In the case of shed, it may be just double or more than that, maybe the maximum duct velocity, maybe 10 meter per second, maximum entry velocity of air into the grain may be kept 0.15 meter per second, and the most common air flow rate for aerating paddy ranges from 0.07 to 0.28 cubic meter per minute per ton. So, depending upon the different types of grains, their condition, their humidity and all those things, what is the aeration facility or aeration and fumigation etc. should be decided. Then another important aspect is the control atmosphere storage of grain as well. We have already discussed in the earlier classes what in the fruits and vegetable, what is the control atmosphere or what is the modified atmosphere, but these can be applied as well to the grain. You can see here that is low oxygen chamber for the grain storage is shown in the figure. So, if the oxygen chamber is low, obviously respiration is less, at a lower rate heat generation will be less and the grain can be cooled for longer time and its shelf life. Similarly, the modified atmosphere packaging, that is in the grain in the different bags etc. like Polyflex and other bags can be used, where inside the bag the atmosphere is maintained and these bags are kept in some sort of storage environment. So, CAS MAP storage of grains, the temperature normally is reported that 20 to 29 degree Celsius temperature of CAS facility is effective in controlling almost all stages of the 12 most common insect species which infest the food grains. That is in the table I have given, that is like oxygen content less than 1% the nitrogen, it controls all the common insect pest and exposure time required to control maybe 20 days for 20 days. Similarly, carbon dioxide concentration, varying concentration 40, 60 and 80% if they are given for 16 days, that is when it is 80% CO2 it becomes effective in controlling. So, pressurized carbon dioxide at more than 20 bar, it is a exposure period of 15 days, it controls the common insects. So, control atmosphere at storage or modified atmosphere packaging of the grains is beneficial because it provides atmosphere which is lethal to storage insects and pests within the reasonable time. There is no harmful effect on the grains. Extended period of storage is obtained without any fungal infection and so on. So, now there is another important, that is stored grain should be analyzed for its quality to know that whether the grain is good or bad or it has spoiled. So, we will discuss this aspect in the next class as well, maybe next after that, but the various characteristics like genetic characteristics of the material like gelatinization temperature, gel consistency, aroma, grain shape and size, bulk density, thermal conductivity, equilibrium moisture content or acquired characteristics like moisture content, color and chalkiness, purity, damage, cracked grain, immature grain or milling characteristics, particularly in the case of rice etc., head yield, whiteness, milling degree. All these parameters are taken as a criteria to judge the quality of the stored grain or quality of the grain, how these parameters are changing during the storage, how they are maintained, that should be analyzed properly. Okay. And if there is a major quality losses or quality changes in the grain during storage, there may be loss or gain in weight depending upon whether moisture absorption has taken place or the grain has dried out. There may be changes in the physical appearance, loss of the nutritional value, loss of the culinary properties or sensory attributes or total destruction of the grain as depending upon the conditions. So, of course, there are different methods available in the literature or their methods are available which should be used to control the losses or check the quality, and they may depend upon visual inspection, chemical and microbiological analysis, insect detection probes can be used or machine vision systems, near infrared or NIR system, electrochemical sensors, electronic nose, acoustic methods etc. So, in fact, these methods also, some of these important methods, particularly the quick methods etc., we shall discuss their details in next class. Then visual inspection methods normally used to detect cracked, immature and discolored grains, or even to find out insect infested grains during storage or during other conditions. If they develop crack, even in the field when they are harvested, some grains may be immature or some. So, by visual inspection or by manual methods they are removed. Then measuring foreign matters like screening of sieves consisting of perforated metal plates, maybe of national standards or international standard organizations. These different perforations, different sieves are used, and then they can, using these sieves, the foreign matters etc. can be sometimes stones etc. which may come, or iron pieces etc. which might come from different harvesting or drying machines, utensils etc. or from the threshing yard. So, they can be removed by using magnetic separators and all those things. Similarly, the moisture meter, there are different types of moisture meters are available in the market, like NIR based moisture sensors, infrared based moisture sensors and other sensing probes etc. are available. Chemical method is available. So, depending upon that is whether chemical methods normally, although they are provide good reliable data which is used commonly in the laboratory, but it is a time consuming process. So, quickly there are the various sensors or probes, as you can see in this picture, they are available. They can be work on NIR technology or such other technologies. They can measure even they can be used for online measurement of the moisture in the tree. So, the factors to be considered while selecting a moisture meter, obviously there is a depends upon what is the resolution of the instrument and what is the level of accuracy provided by the data, reliability of the data, repeatability, stability, range of commodity and range of the moisture content which it can efficiently measure, sample size, sample weighing, ambient effect etc. So, with this I think we have a good coverage of the grain storage structures, different types of storage structures which are used traditionally as well as improved storage for the grain. So, at the end, the most important thing is that the storage structure should be selected properly, the conditions inside the storage, all right, depending upon the grain, as per the depending upon the requirement of the grain, the proper ecosystem should be maintained, so that the grain shelf life is maintained to the maximum level. It is prevented from the insect, pest and other attacks, and also the quality of the grain should be monitored or should be measured periodically to assess the level of the spoilage or how it is, or its finding out its shelf life or its usability. Thank you very much.